Imagine standing beside a machine powerful enough to erase a towering building, one crushing bite sending concrete exploding into dust. You hear steel groan, windows shatter, and engines roar, yet every movement follows an astonishing engineering plan with incredible precision. Most people think demolition means destruction, but experienced engineers see the beginning of an entirely new construction story. Every controlled collapse begins months before engines even start, with engineers studying every beam, column, bolt, and hidden danger. But here's what nobody tells you. The machine itself weighs more than dozens of family cars combined. Some ultra-high-reach demolition excavators stretch over 60 meters, reaching heights comparable to nearly 20-story buildings with remarkable stability. Think about this. The operator controls thousands of moving components using fingertips, transforming unbelievable force into astonishing surgical accuracy every single second. Hydraulic cylinders multiply human strength thousands of times, squeezing reinforced concrete until it suddenly fractures with thunderous cracking sounds. Every crushed wall gets sorted into reusable steel, recycled concrete, and valuable materials that begin another industrial life almost immediately. And this is where it gets truly extraordinary, because these incredible machines aren't simply destroying buildings, they're carefully harvesting tomorrow's construction materials. Before this demolition giant ever touches a building, its journey begins deep inside iron ore mines scattered across several continents. Australia supplies nearly 60% of the world's seaborne iron ore, feeding steel mills that build these incredible machines. Brazil contributes another enormous share, where exceptionally high-grade ore often exceeds 65% iron before refining even begins. That valuable ore travels thousands of kilometers aboard bulk cargo ships before reaching some of the world's busiest steel factories. Inside blast furnaces, temperatures soar beyond 1,500 degrees Celsius, transforming raw ore into glowing molten iron ready for steelmaking. Most people never think about this, but recycled scrap steel often becomes just as important as freshly mined metal. Electric arc furnaces melt recycled steel using powerful electrical energy, reducing mining demand while producing remarkably strong structural alloys. Special alloy ingredients like chromium, nickel, and molybdenum strengthen hydraulic components against incredible pressure, friction, corrosion, and constant vibration. Without those carefully balanced alloys, enormous hydraulic cylinders would wear rapidly under crushing forces exceeding hundreds of tons every day. Natural rubber from Southeast Asia eventually becomes heavy-duty seals protecting every hydraulic system from dangerous leaks and contamination. Copper mined in Chile and Peru carries electricity through hundreds of sensors, cameras, computers, and advanced electronic control systems. Think about this. One demolition machine contains materials gathered from thousands of workers across multiple continents before final assembly even starts. Yet every shipment faces storms, traffic, customs inspections, and delays that could stop an entire production line without warning. What happens next surprised even experienced engineers, because thousands of individual parts must become one unstoppable demolition giant with astonishing precision. Now the real transformation begins as thousands of precision components arrive, ready to become one powerful demolition machine. Gigantic steel plates enter CNC plasma cutters reaching nearly 25,000 degrees Celsius, slicing perfectly shaped sections within only a few minutes. Powerful robotic welders fuse massive frame sections, creating joints capable of surviving decades under crushing loads and relentless vibration. Each weld cools under carefully controlled conditions, preventing hidden cracks that could threaten safety years into the machine's demanding service. Massive machining centers spin cutting tools above 2,000 RPM, shaping precision mounting surfaces within fractions of a millimeter. Most people never notice hydraulic cylinders, yet they generate incredible force using oil pressures exceeding 350 bar. Technicians fill every hydraulic circuit with filtered oil before removing microscopic air bubbles that could reduce performance and reliability. Next comes the enormous boom, carefully lifted by overhead cranes and aligned with millimeter precision before permanent installation begins. Think about this. One misplaced pin could affect thousands of moving cycles every single working day throughout the machine's lifetime. The operator's cab receives vibration insulation, climate control, cameras, digital displays, and ergonomic controls designed for long, demanding shifts. Workers install powerful turbocharged diesel engines producing hundreds of horsepower, supplying relentless energy for demanding demolition operations every day. Finally, the hydraulic crusher arrives, its hardened steel jaws engineered to crush reinforced concrete while resisting extraordinary wear and impact. But before this machine earns its first demolition job, it must survive some of the toughest tests engineers can imagine. The real proof begins now, because every demolition machine must earn its strength before it ever reaches a construction site. Powerful computers instantly monitor hydraulic pressure, engine temperature, vibration, and hundreds of sensor signals every single second during testing. Artificial intelligence compares live performance against thousands of previous tests, spotting tiny problems long before humans could ever notice them. Laser scanners measure critical components with astonishing accuracy, detecting dimensional differences smaller than a single human hair across massive steel structures. Some mounting points allow tolerances as tight as 0.05 of a millimeter, demanding extraordinary manufacturing precision every single time. Hydraulic systems operate continuously under crushing loads, proving every seal survives intense pressure without even the smallest dangerous leak. The entire machine shakes violently on vibration platforms, simulating years of demanding demolition work within only several exhausting testing days. Most people never imagine these machines repeatedly crush massive concrete blocks before receiving final approval for real demolition projects. Quality inspectors carefully examine every weld using ultrasonic equipment capable of revealing invisible internal flaws hidden beneath polished steel. Factories reject even tiny imperfections because reliability matters more than production speed when human lives depend on every machine. Yet one remarkable step still depends entirely on experienced human hands instead of advanced robots or artificial intelligence systems. That final alignment comes from years of experience, where tiny vibrations felt through fingertips reveal details machines still cannot understand. And this is where everything changes, because the world's biggest demolition machines are about to reshape entire cities before your eyes. By now you've seen how these incredible machines are built, but their worldwide impact is even more astonishing than their engineering. Every year, manufacturers produce thousands of demolition excavators and specialized attachments supporting construction, mining, recycling, and infrastructure projects worldwide. The global demolition equipment market is valued in the tens of billions of dollars and continues expanding as cities modernize. China leads global demand, followed by the United States, Japan, Germany, and South Korea, each driving advanced heavy equipment innovation. Together, these industries employ millions of engineers, welders, operators, mechanics, software developers, inspectors, and logistics specialists around the globe. Think about this. One machine represents the combined knowledge of thousands of skilled people working across dozens of different industries. Did you know some demolition attachments weigh more than an entire city bus, yet still move with remarkable precision every day? Did you know modern demolition projects recycle enormous amounts of concrete and steel, dramatically reducing landfill waste and conserving natural resources? Did you know some demolition robots safely enter dangerous structures where sending human workers would simply be far too risky? Over the next decade, smarter automation, cleaner power systems, and artificial intelligence will completely redefine how buildings safely disappear. From distant mines to advanced factories, you followed the remarkable journey behind the world's most powerful building demolition machines. What once looked like simple destruction now reveals decades of engineering, precision manufacturing, and thousands of skilled hands working together. Every hydraulic hose, every steel pin, and every welded joint carries a story hidden beneath layers of incredible technology. Tomorrow's demolition machines will become even smarter, cleaner, quieter, and safer while transforming cities faster than ever before. The next time you watch a building disappear, remember the incredible journey hidden behind every calculated movement and crushing force. Behind every successful demolition stands an extraordinary chain of miners, engineers, machinists, programmers, mechanics, inspectors, and skilled operators. Their combined expertise transforms raw materials from across the world into machines capable of safely reshaping entire cities. If this journey changed how you see heavy machinery, you're only beginning to discover the hidden world of industrial engineering. Tell us which incredible machine or manufacturing process you'd like us to explore next in a future documentary adventure. Like this documentary, subscribe for more engineering stories, and we'll meet you inside the next factory. Fade to black.